Quantum computing. Imagine a computer that doesn't just think faster, it thinks differently. Welcome to the world of quantum computing, where the rules of classical computing are rewritten by the strange and fascinating principles of quantum mechanics. But don't worry, you don't need a degree in physics to understand it. Today, we'll break it down step by step so that even if you've never heard the term quantum before, by the end of this, you'll not only know what quantum computing is, but why it's considered a technological revolution. Let's start simple. Computers, as we know them today, our laptops, phones, and even supercomputers, are classical computers. They process information in binary, zeros and ones. Think of these as tiny switches, where 0 is off and 1 is on. All the apps, websites, and calculations we use rely on strings of these zeros and ones. Quantum computing, on the other hand, is built on qubits, quantum bits. Unlike classical bits that are strictly 0 or 1, qubits can exist as 0, 1, or both at the same time thanks to a property called superposition. This ability to be in multiple states simultaneously gives quantum computers their incredible potential. Great question! Here's a metaphor. Imagine you're in a library looking for a specific book. A classical computer searches row by row, which can take time. A quantum computer, however, acts like it's in every row at the same time, drastically speeding up the search. This means quantum computers can solve certain problems exponentially faster than classical ones. They're not just faster calculators, they're a completely new way of solving problems that classical computers find impossible. To understand how quantum computers work, we need to peek into the principles of quantum mechanics, the science of the very small. Picture a spinning coin. While it's spinning, it's neither heads nor tails, but a mix of both. In the quantum world, qubits can exist in this spinning state of 0 and 1 simultaneously. This means a quantum computer can process a huge number of combinations at once. This is a bit like a sci-fi connection between qubits. If two qubits are entangled, the state of one instantly affects the state of the other, even if they're miles apart. This interconnectedness allows quantum computers to perform complex calculations incredibly efficiently. Quantum computers use interference to amplify the probabilities of correct answers, while canceling out incorrect ones. Think of it like noise-canceling headphones, but for calculations. Quantum computing is still in its infancy, but its potential is vast. Here are some real-world applications. Developing new medicines involves simulating molecular interactions, which is computationally expensive. Quantum computers could simulate these interactions much faster, leading to breakthroughs in treatments for diseases like cancer and Alzheimer's. Today's encryption methods rely on the difficulty of factoring large numbers, a task classical computers struggle with. Quantum computers could crack these codes in minutes, revolutionizing cybersecurity. AI relies on analyzing vast amounts of data. Quantum computing could supercharge machine learning algorithms, making AI smarter and more efficient. Predicting climate changes requires analyzing countless variables. Quantum computers could process this data more accurately, helping us combat global warming. From improving traffic flow in cities to enhancing supply chain logistics, quantum computers can quickly find the most efficient solutions. It's important to note that quantum computers aren't here to replace classical computers. They're designed for specific types of problems, especially those involving massive amounts of data and complex calculations. For tasks like checking emails, browsing the internet, or playing video games, classical computers remain more practical. Additionally, quantum computers are still experimental. They require extremely cold environments, close to absolute zero, to function, making them challenging and expensive to maintain. Feature vertical bar, classical computing vertical bar, quantum computing. Quantum computing, a beginner's guide to the future of technology. Basic unit vertical bar bit, 0 or 1, vertical bar qubit, 0, 1, or both. Processing speed vertical bar, sequential vertical bar parallel due to superposition. Applications, general purpose specialized problems. Error tolerance vertical bar, high vertical bar low, prone to errors currently. Development stage vertical bar, mature vertical bar, emerging vertical bar. The quantum revolution is driven by tech giants, startups, and research institutions. Here are a few key players. IBM offers cloud access to quantum computers, making it easier for researchers to experiment. Google's quantum computer, Sycamore, achieved quantum supremacy by solving a problem in 200 seconds that would take classical supercomputers 10,000 years. Focused on developing a scalable quantum ecosystem, a startup developing cloud-based quantum systems, specializes in quantum annealing, a specific type of quantum computing. Quantum computing sounds amazing, but it's not without hurdles. Qubits are extremely sensitive to their environment. Any disturbance can cause errors, which researchers are working hard to minimize. Building a quantum computer with enough qubits to tackle real-world problems is a massive engineering challenge. Quantum computers are expensive and currently only accessible to large corporations and research institutions. If this field excites you, there are many ways to dive in, even as a beginner. Platforms like IBM Quantum Experience and Microsoft Azure Quantum offer free tools to experiment with quantum programming. Websites like Coursera and EDX have beginner-friendly courses on quantum mechanics and computing. Follow quantum news, blogs, and research to stay informed about the latest developments. Start coding with quantum programming languages like Qiskit, Python-based, and Cirq. We're on the brink of a quantum revolution, but there's still a long way to go. Experts predict that within the next 10, 20 years, quantum computers will transition from experimental machines to practical tools solving problems we can't even imagine today. Whether it's curing diseases, safeguarding our digital lives, or unlocking the mysteries of the universe, quantum computing promises to redefine what's possible. Quantum computing isn't just a buzzword, it's a glimpse into the future of technology. While the science may seem complex, its potential is simple, solving the unsolvable. So, whether you're a tech enthusiast, a student, or just curious about the future, now's the time to explore this exciting field. Who knows? Maybe one day, you'll be the one programming the next quantum breakthrough.